Hello, I'm going to show you how to find the nth term of a linear sequence. So a linear sequence is a sequence of numbers that has a common difference. So if we look at the sequence I've put up here, between 7 and 10, I add 3. Between 10 and 13, I add 3. 13 to 16, I add 3, and so on. So the difference between each term is 3. So the term-to-term sequence would be I start at 7 and then I add 3. But we don't want the term-to-term sequence, we want the nth term sequence. And this is where this little formula up here comes in really, really handy. So in the case of this sequence, the D is our difference. So the difference in this case is 3. So 3 becomes the coefficient, the number before the n term. So it says this sequence is a little bit like the 3 times table. But obviously it doesn't start at 3, it starts at 7. So how do we work out what this needs to have an adjustment of? Well, the simple way to do it is to look at the first term, which is what we call A. So I'm just going to put plus, then in brackets A, which is 7. And then I'm going to take away the difference, which I've already said is positive 3. Now, if I simplify this through, I get my sequence as 3n plus 7 take away 3, which is 4. Now, it's always a really good idea just to double check you've got the right sequence here. So if n was 5, the fifth term in the sequence, 3 times 5 would be 15, plus 4 would be 19, which is indeed the fifth term in the sequence. Another good way to check is if you put your finger over the n and look what the numbers that you're left with. So I've got a 3 plus 4. 3 plus 4 is 7. That should be the first term in your sequence. If it's not, go back and check and make sure that you've worked out the common difference correctly and use the formula correctly. Okay, let's do a couple more examples. And then there are some examples on the PowerPoint that you can have a go at yourselves. So, our next sequence, let's look at the common difference. Plus 5. Plus 5. Plus 5. And the reason I don't just do the first one is I want to double check to make sure it is a linear sequence. If that was plus 5, that was plus 6, that was plus 7, it would be a different sort of sequence and I wouldn't be able to use this formula. So D stood for the difference, the common difference between each of these terms. So my number before the n is going to be a 5. So 5n, so like the 5 times table, this time though it's starting at 1. So what's the adjustment that I'm going to need to make? Looking at the formula, my first term was 1 and then my difference that I've got to take away was 5. So again I can simplify that to 5n plus 1 minus 5. Well, 1 minus 5 is going to be negative 4. So plus negative 4 just means I'm going to take 4 away. Now again, my little check, I'm just going to put my finger over the n. 5 take away 4 gives me 1, which was the first term in the sequence. And if I just want another check, 5 times 5 would be 25. Take away 4 would be 21. So the fifth term in the sequence should be 21, and indeed it is. So we've looked at sequences where we've been adding to get to the next term. Let's just do one where we are going to subtract. So what's happening here? It's a decreasing sequence. So I'm going to take away 6 to get from one term to the next. So keep on taking away 6. This means that the common difference, the number before the n is going to be negative. It's going to be negative 6n. So a little bit like the negative 6 times table, but it doesn't start at negative 6, it starts at 9. So what do I have to do to adjust this sequence to get to this sequence? Let's see, plus a, remember a was the first term, which was 9. Take away the common difference. The common difference was negative 6, so take away negative 6. So hopefully remembering how we work with negatives, taking away a negative is the same as adding. So this sequence becomes negative 6n plus positive 15, so plus 15. Now, you might also see this type of sequence formatted slightly differently. Rather than having the negative at the start, another way, an equivalent way of saying this sequence would be 15 minus 6n. But both of these mean the same thing. Let's just double check. Minus 6 plus 15, that's going to get me to 9. And if if n was 5, minus 6 times 5 would be negative 30, plus 15 would be negative 15. So there's a couple of checks you can always put in place just to be absolutely sure you've got the right answer. Now have a go at some of the questions on the PowerPoint, and do let me know if you need any extra help.